Okay, so these are our day one notes. Starting with probability basics, are the past patterns present in the current bracket, types of runs, short run, regularity, surprise meeting, law of averages. These are all things we're about to learn about here. And we're going to talk about basic probabilities that will be helpful in your first round calculations. So first we're going to come up with the definition of random. So if something is random, for example, rolling a die, I gave you all a die, right? Why would I say it's random what you get each time? If I roll the die, do I know what I'm going to get? No. If I roll the die 600 times, about how many times am I going to get a 1? About 100 times, right? So in the short term, I don't know what I'm going to get. In the long term, I know about what I'm going to get. So random is going to be, here we go, sorry. Individual outcomes are uncertain, but there's a regular distribution in large repetitions. If I roll a 3, I really don't know that I'm not going to get a 3 next. I have a chance of getting a 3 next as well. But if I roll this die a lot of times, I know that about a sixth of the time I'm going to get a 3 because there are 6 sides. So for random, on the first line, you're going to write this definition. And where it says example with dice, you can say that you don't know what you're going to get for one roll. But if you roll it a lot, about a sixth of your rolls will be a 3. Or whatever number you like. A sixth of your rolls will be a 2. Okay? So please put the example with dice in your own words. Alright, the probability of an event is going to be between 0 and 1. So if there is a 0% chance of something happening, then your probability is 0. If there's a 100% chance of something happening, then your probability is 1. 50% chance, what would your probability be? 0.5. Excellent. All right, when you finish with that one, think about whether you know what a run would be. Anybody know what a run is?
Like when you run.
Could be. In probability, what is a run? Exactly. When you get the same result multiple times in a row. So, you guys have been rolling your die. Has anybody gotten a run yet? Nobody got a run? Roll your die. See if you can get a run. Oh, I just got a run of 2 5s. It's kind of less of a run if it's just 2 times. See if you can get 3 in a row of something. It's hard, right? The odds are not really in your favor to get 3 in a row of something. All right. So, oh, I skipped over that one. Probability theory is right there, and then we'll get to run. Sorry. Fill in probability theory, mathematical study of randomness, and then we'll go to run. Anybody get a run in all that? Did you get 2 or 3? Wow, you're really lucky. Is that because you're a triplet? Could be.
Yeah.
You should test it out with the others. See if they also can get 3. All right, so here's run, repetition of the same result, and feel free to write down what the example is. The example is that you could get multiple of the same number in a row. Doesn't count if it's not in a row. So like getting 5, 5, and then 4, and then 5. That doesn't count as 3 5s. Okay. Short run, regularity, a streak of the same outcome. So that's pretty much what we were just talking about. Streak of the same outcome. So that's what we're talking about when we had several rolls of the same number. A surprise meeting. Okay, that sounds like a funny thing for a math concept, but it's exactly what it sounds like. Unlikely chance that an event will happen. So for example, if I told you I'm going to bet you that I can roll 2 1s in a row, chances are that's not going to happen. That would be a surprise meeting if I were right. You might even question my die, whether it's weighted or something, because somebody shouldn't bet on something like that. All right, and then the law of averages. I don't really like this definition. I'm going to edit it just a little bit. It says, if there's a streak, it's more likely to get the other result, not really in your next roll, just eventually. All right? If I get a 5, and a 5, the chances that I'll get a 5 in my next roll are still 1 in 6. There's no less chance I'm going to get a 5 in my next roll. There's also no greater chance I'm going to get a 5 in my next roll. So just because you got a bunch of 5s doesn't mean the next one's not going to be a 5. But eventually, I'll get something else because of the law of averages. If there's a streak, we are more likely to get the other result. Eventually, it will balance out. Okay, so here's 2 short definitions, but I want you to take a minute to think about the questions next to them. Risk is exposure to danger, so you'll write that down. And then the question I asked is, what would be a risky dice bet? Simulation imitates chance behavior. And the question next to it is, how could I simulate rolling a die? So if I didn't have dice with me, what could I do to simulate it? So feel free to talk about those answers with your group, and I'll ask you in just a minute for those. So if you didn't put down what would be a risky dice bet yet, you could put down getting 1 twice in a row would be a risky dice bet. Does anybody know why somebody would take a risky bet like that? The rewards could be greater because it's such a bad bet. So the chances of getting 1 twice in a row are 1 in 36. So if the game were even, you would bet $1 and you would get $36 if you were right. You would lose $1 if you were wrong. You would get $36 if you were right. Usually games aren't even in your favor, but still people make these bets. Okay, raise your hand if you have an idea about how could I simulate rolling a die. Did anybody figure out how you could simulate rolling a die? If I'm a random number generator, excellent. And I would make my max number what? 6. Yes, you could use a random number generator and your max number would be 6. So that could be a simulation. Very good. All right, moving on. Maybe. Okay, independent. So events are independent if knowing the outcome of one doesn't change the outcome of another. So that goes on the first line for independent. Knowing the outcome of one doesn't change the outcome of another. On the second line, we can put in an example. So think about your die again in your hand. If I roll a 6 once, does that change my odds of getting a 6 the second time? It doesn't. And that's something people have a hard time understanding. Like, it's intuitive for people to think that if you roll a 6 once, you're less likely to roll it again. You have the same chance. Once you've already rolled a 6, then you have a 1 in 6 chance of rolling it again. If you haven't rolled at all, then you're talking about two different events. But if I roll a 6, I have the same chance of rolling a 6 again. So make sure you put an example on the second line. For example, you could write what I just said. Rolling a 6 once doesn't change your chance of getting a 6 the second time. Probability model. A probability model lists all possible outcomes and the probability for each event. So let's see if I can write a probability model here. Maybe I'll do a text because I'm no good at writing on this. All right, so my probability model, what are the things I could get when I roll a die? I could get a 1, right? What's the chance that I get a 1? 1 out of 6. Very good. I could roll a 2. What's the chance I roll a 2? Still 1 out of 6. Same. I could roll a 3. 1 out of 6. 4. So notice I'm listing all the outcomes and the chances. I mean, a die or a coin is going to be the same, but some things aren't the same. Okay, so I listed all the different numbers I could get and the chance of getting each number. That's a probability model. And then simpler than that is the sample space. The sample space just lists all the possible outcomes. Sample space. Guys, I don't mind if you roll these dice while we're working. I think sometimes it helps you focus to fidget with something. All right. Once you get that down, you are ready to look at example 1. If you toss a fair coin 3 times, what is the probability of getting 2 heads and 1 tail? So what we're going to do is we are going to create the sample space to try to figure that out. I'll get you started so you see what it looks like. Okay. So we need to list all the things that could happen if we roll the die, or no, if we roll the coin 3 times. So, what could I get on my first try? I could get heads or tails. Pick one. Heads. Okay. So say I get heads on the first one, and actually let's just say I get all 3 heads. That's one thing I could get. Right? It's possible. Heads, heads, heads. All right. Next one, the last one could be tails instead. So it could be heads, heads, tails. Or the middle one could be tails. Okay. Are these all the possibilities with heads coming first? No, because they could both be tails, right? So heads, tails, tails. So I've done half of them. I want you to do the other half of the sample space. Figure out the other things that could happen besides these. So I'm going to start with tails now. I'll do tails, tails, tails. What's another one? Tail, tails, head. What else? Tail, head, tail, and what's the one I'm missing? Tail, head, head. Good. So these are all the possibilities of flipping a coin 3 times. So now we can answer the question, what is the probability of getting 2 heads and 1 tail? So how many ways could we do it? 2 heads and 1 tail. 2 heads and 1 tail. Is there another one? Oh, this one, right? Okay, so 3 ways out of how many possibilities? Out of 8. Very good. Anybody remember what this is called when we list all the possibilities? It's alliterative. Sample space. Good. Okay. So when you are done with that, turn the page. We have a few more definitions to do, and then we'll have some more examples. All right, event. Any collection of outcomes from some chance process. So, an event could be heads. An event could be 6. An event could be the Jack of Hearts. Or it could even be like we had before, the event could be 2 heads and 1 tail. It could be 1, 3, and 1, 4. These are all events. Alright, and then we have a list of the basic rules of probability. So the first one we talked about already, but we want to include it in our basic rules. All possible outcomes sum to 1. So let's think about that in terms of the coin flip for a second. I'll add another text box if I can. So the probability of heads, that's kind of too large. I need to make that smaller. Is 0.5, 50%. The probability of tails is 0.5, and those are the only possibilities. So if you add the possible outcomes, you should always get 1. The probability an outcome doesn't occur is 1 minus the probability it does. So let's do that with dice. So the probability that we don't get a 6 is 1 minus the probability of a 6. Actually, let's change that to a different number. I'll say 5 because it's going to be confusing with the 1/6. So the probability we don't get a 5 is 1 minus the probability of a 5. Which would be 1 minus 1/6, which is 5/6. The probability that we don't get a 5 is 5/6. If no outcomes are in common, the probability of one or the other happening is the sum of both. So the probability that we roll a 3 or a 4 is going to be 1/6 plus 1/6, which is 2/6 or 1/3. And then the last one, if all outcomes are equally likely, then the probability of A happening is the number of outcomes related to A divided by the total number of outcomes in the sample space. And that's what we just did with our heads and tails problem. So sometimes putting a lot of words on something makes it sound more complicated than it actually is. So we were on the slides and we got here, and then the probability of an event occurring is actually the thing we just wrote. So if your hand needs a break, you can just take what we just wrote, and the probability of an event occurring goes right there. The probability of an event not occurring, if you were here for the Venn diagrams, you'll remember that the not is like, it looks like a little apostrophe. So it's written this way. Complementary event means the probability of an event not occurring. It's written like this, P of not A. And like we said before, actually related to what we said before, the probability of an event happening plus the probability of an event not happening is 1. Okay, there is a 100% chance that I will either give you homework or not give you homework. Okay? The probability of an event happening plus the probability of the event not happening is 1. So in dice, the probability of getting a 3 plus the probability of not getting a 3 would be 1 in 6 plus, what's the probability of not getting a 3? 5 in 6, good. So 1 in 6 plus 5 in 6, which equals 6 in 6, which is 1, just like we predicted. All right, so I'm going to pause for a minute while you guys try example 2. In example 2, a marble is selected from a box that has 5 green, 3 red, and 7 blue marbles. And you need to find the probability that the marble is all of these events. How many marbles are there altogether? 15, okay? So remember that there are 15 altogether when you're doing this. Okay, I want you to compare your answers to Kayla's. Alright, so we're on example 3 now. Consider the following farm animals: horse, cow, rooster, duck, pig, sheep, chicken. What is the probability that the animal has 4 legs, does not have feathers, is taller than your waist? I don't know about that one. Which of those animals is taller than your waist? A horse and a cow. A sheep, do you guys think? Yeah? Okay. So taller than your waist, we'll go with the horse, cow, and sheep. Alright, so go ahead and answer those. Compare with your neighbors. How many of those animals had 4 legs? The horse, what else? Cow. Pig and sheep. So that would be 4 out of what?
4 out of 12.
4 out of 7 animals. Oh, is it frozen?
Yeah.
Thanks.
Close enough.
So 4 out of 7. All right, does not have feathers. So horse again, what else? Cow. Is it pig and sheep again? So same ones. And 4 out of 7 again. Taller than your waist. This time we left out the pig, right? So just horse, cow. The sheep I think is kind of iffy. Depends if it's a tall sheep and if you're a tall person, but we'll go with that. So that's just 3 out of 7. All right, so you have an activity in front of you. On the front, you're going to do the activity with your group. Make sure you agree on your answers. Then if you look at our board over there, after you do that, you're going to run to the restroom, wash your hands, and then you're going to come back and do the activity 2, which requires Skittles.